Hello everybody, welcome to this webinar. My name is Mernush Khabiri. Today I'm going to present electric motor or machine designs using ANSYS software. Just a little background about Ozen Engineering Inc. Here in Ozen Engineering Inc., we are ANSYS channel partner and distributor. We sell ANSYS software product and we have training and technical support for that in California. Also, we have consulting services and do simulation project for our customers. We are located in Sunnyvale and we have over 25 years of experience in finite element analysis and simulation. Most of you may be familiar with the ANSYS product, but ANSYS develops engineering simulation softwares and offer multi-physics simulations. And ANSYS is market leader in finite element analysis, also in CFD and electromagnetic analysis. Also, ANSYS offers some human body models with detailed body part, over 300 body parts like muscle, organs, which are frequency dependent, and they are very useful for biomedical applications or health applications for looking at the electromagnetic distribution and power absorption by human body. The point of using simulation, basically simulation help you to predict how your product design will behave and how manufacturing process will operate in real world environment. Basically, in fact, it saves you a lot of time and money before you commit to any before you committing to the physical world or actual prototype. So as you can see here, before that it was just a design, just going to the prototype, testing and getting back with another design. But right now with using simulation, you can get a really good approximation of your device performance and get it to the fabrication and prototype. Here you can see the ANSYS technology. ANSYS covers electromagnetic product in high frequency, HFSS, SI wave, Q3D, circuit design or designer, and in low frequency for electromechanical applications, softwares like Maxwell and Simplorer, in structural mechanics from linear static to high speed impacts, and in fluid mechanics from single phase flows to multi-phase combustion, and also systems, full system analysis. But today I'm going to focus in a low frequency product for electromechanical applications like electric machine designs. ANSYS offers design methodology for electric machines. Basically, there are 5 combinable tools in designing and analyzing electric machines in ANSYS. So first one is the RM Expert, which is the template-based analytical software for motor and generator designs. Also Maxwell 2D and 3D, which is a software based on finite element method. Simplorer for system and circuit analysis. And Optimetric option, which is for parametric analysis and also optimizations, and also ANSYS Mechanical and CFD for thermal, stress, and acoustical analysis in the motor designs. This image somehow shows how these tools work with each other and how is the design flow for electric machines. Basically, you can start with the RM Expert and design, basically narrow your designs based on sizing, magnet size, material, and then easily you can create a model in a Maxwell 2D or 3D. It automatically generates the 2D and 3D models and do the final element analysis. And also you can use the toolkits for thermal design, for thermal analysis. And you can have an efficiency map can be created by taking measurement in a test environment of the output torque, input power, and output power. This is again, it's a flowchart that shows you how the ANSYS electromagnetic, ANSYS electromechanical design flow works. You start from the RM expert and Motor-CAD for the initial design, and then you take it to the Maxwell 2D, 3D for final element analysis. So in this, in Simplorer, you can design the full system, motor drive, circuits for excitation, inverter, and whatever you need for your full system design. So you can use CFD and mechanical for esters and thermal analysis. Basically, it's a multi-physics package, and you can use all of these in a single environment, a common environment. I'm going briefly going through these softwares and talk about their capabilities. ANSYS Maxwell is based on the finite element method. It's solving Maxwell equation based on quasi-static, and so it has 2D and 3D software as well. It's integrated in ANSYS Workbench, so that's the advantage that you can use them, have the multi-physics simulation. It has different solution type like electrostatic, magnetostatic, transient, eddy current for different applications, and you can look at the torque, magnetic field, efficiency, saturation, and whatever is the result that you need to see for your product design. And there are it covers different applications: power supplies, motor generators, transformer, magnetic sensors, cables. So you can it has the really wide variety of application. It covers all of them. Maxwell is really powerful in creating the geometry. So it has a library of the essentials of the electric motor designs that you don't need to create those parts from the scratch. So that's really helpful. Basically, all the essential component for most of the machines already included in the library or user-defined. These are like user-defined components, so it would be really helpful for creating your geometry and have the CAD file of your geometry. And one of the other advantage of the Maxwell is that you have the adaptive and automatic meshing. And so you don't need to be worried about mesh. It starts with the initial mesh from the geometry, as you can see here, and it calculates the field and calculate the field accuracy. Basically, it's trying to satisfy the criteria and see if it's the error acceptable. It's gonna display the simulation result. If not, it's gonna do the mesh refinement and do the field calculation again, and goes this process again. So you can see that it's starting with the initial mesh, but in the final mesh we have more fine mesh in some areas that are required to have finer mesh. And also this slide, this animation shows you that how automatic and adaptive meshing working. So it's starting from the initial mesh, and you can look at the response and the automatic adaptive mesh refinement continues to get to the stable result. In Maxwell, you can have different excitation for excitation of like current, voltage, but you have an option of circuit design also. So your excitation can be from external circuit. So you have a circuit design coupling through the Maxwell. So you can use the Maxwell circuit editor for control and drive circuitry, or for your source as excitation. One of the other features of that help you a lot in your design process is Optimetric. Optimetric consists of parametric analysis, optimization, sensitivity, tuning, and statistical analysis. So using these features help you to find the best values for your parameters to have the best performance of your device. So this is a very helpful feature for in the designs. And the other option is high performance computing. You can do simulation across multiple processors and computers, basically performing simulation in parallel, and it decreases the computation time. And for sure it's going to enhance engineering productivity. So it's going to make it faster. As you can see here, when you have multiple core and using HPC options, you're going to have parallel tasks in the running. RM Expert is another tool that which is very useful for electric machine designs. RM Expert is a template-based analytical software for motor designs. You can calculate machine performance, decide about the material, magnet sizing, pole or stator sizing, and gaps. You can have your initial design start your initial design through the RM Expert. And the good thing about RM Expert is that it has the library of common machine types. As you can see here, these are the different machine types that are included in the RM Expert library, like the synchronized machines, brushless permanent magnet, DC motors. So you have different kind of the motors that you can start your initial design over there and calculate the performance of the machine. Also, you can do use the Motor-CAD for the thermal analysis. So basically, you can use RM Expert as a template-based software. So you can select your machine design. So it's going to like a fast and simple analysis, and then with just one click you can transfer the model to Maxwell 2D or 3D. It automatically generates the 3D model from the RM Expert design, and also you have an option to do the heat transfer or thermal analysis, and you have some options in Motor-CAD for cooling systems. So you have options and capability in RM Expert to make some changes in the template-based motor and generators. Basically, you can change the winding, choose your wire, or change the stator, rotor topologies, and all of these things. So you have an option to change everything based on your design requirement. And as I mentioned, you can easily transfer your model from the RM Expert to Maxwell 2D or 3D. So after you setting your simulation in RM Expert, easily you can right click on Setup and say Create Maxwell Design. You have a choice for 3D design or 2D design, and automatically it's gonna create a model even with considering the symmetric, if your model is symmetry, 3D model in the Maxwell 3D or a 2D model. And also you have in Maxwell a user-defined primitive is being created uh, to ease the geometry share and geometry share with Workbench. So when you have you need like thermal analysis coupled with the electromagnetic simulation, you can use the user-defined primitive for this goal. Also, as I mentioned, you have the Motor-CAD option for the thermal analysis. Motor-CAD is a template-based thermal design, and it providing an extensive range of the cooling type like spray cooling, wet rotor, wet stator cooling, water jackets. So it has a different option that you can use for cooling. And you can basically it performs both a steady state and transient analysis too. The thermal sizing environment provide 2D thermal finite element solver integration, and which allows fast calibration of analytical method. As you can see here, I mean, Motor-CAD fully integrated finite element analysis thermal solvers, it's really help for your thermal analysis in your design. The other software is that you can use and is really useful in your electric machine design is Simplorer. Simplorer is basically Simplorer allows you to analyze all aspects of large scale system, from detailed component analysis to system performance in single virtual design environment. It solved the electromechanical systems, DC, small and large signal AC, transient models. So it has the circuit simulator, state machines, it has block diagrams and all of this. So basically the applications are for power electronic, motor drives, and mechatronic systems, also in all the power systems and power distribution. So you can see here basically what kind of the simulation covered by Simplorer. Digital and analog circuit, state machines, you can have the block diagrams and do the full system analysis based on these options. Also, one of the powerful options of the Simplorer is that it has the co-simulation with other ANSYS products. So in Simplorer circuit, you have a sub-circuit option, and you can bring the designs from different softwares like Maxwell, Q3D, P-Expert, Mechanical, IcePack, HFSS, almost all of the softwares, ANSYS softwares, Simplorer has co-simulation. So like here, you can, in Simplorer area, you can import your motor design, or machine design from the Maxwell project, import it to the Simplorer, and then design the motor drive or control system in the Simplorer. So it's like a bidirectional simulation, so you make any changes in your motor design, it's going to be seen in the Simplorer design. As I mentioned, the most advantage of using Simplorer is that you can have the whole motor drive and system design inside the Simplorer with co-simulation with the Maxwell. So Maxwell can be directly coupled with ANSYS Simulator with the Simplorer. And any nonlinear behavior of electric machine designs can affect the electric drive control. So basically using this option, it's really help you to look at the full system, full analysis of your system and your design. About the multiphysics coupling. So the advantage of using ANSYS tool is that you have option of the multiphysics simulation. Maxwell has basically Maxwell has a coupling with other ANSYS softwares. As you can see here, Maxwell has a coupling, two-way coupling with ANSYS Mechanical for thermal and structural analysis, with Fluent, and also IcePack, which is a thermal software, thermal analysis software. And basically easily through the workbench you can have your Maxwell project and do the electromagnetic analysis. So for further analysis, easily you can transfer the geometry and also the solution to the other software setup. Let's say like here you can bring the geometry and also solution, electromagnetic solution to setup of the static structural analysis, like to do the thermal analysis or stress analysis here. So it's really helpful to have this option, multiphysics simulation. And you can see here like some examples that show how you can take advantage of this direct coupling and doing multiphysics simulation, like for Maxwell-Thermal and mechanical analysis. Basically you have your model, your motor design, you do the electromagnetic analysis, and then bring the forces to the ANSYS mechanical to look at the do the stress analysis, look at the deformation of your model, and also you can bring the losses to the steady state thermal to look at the heat thermal distribution and the temperature distribution on your motor. Multi-physics simulation really helps, and it's gonna I mean you're gonna see it in your result when you don't have you do the electromagnetic simulation or do the both a multi-physics simulation, and it's really shown in you can see the difference. As in this example you can see here you can predict your electric motor performance if you just do the Maxwell simulation, electromagnetic analysis. This red graph shows that with just electromagnetic analysis, the magnet temperature is around 22 degree, but when you do the multi-physics simulation using Fluent and mechanical and considering the loss and heat generation, so then you can see the actual temperature of the magnet is around 53. So you see that in this analysis, if you go with the single simulation, electromagnetic simulation, or with the multi-physics simulation, the actual 60% drop in predicted performance. So basically this way you're gonna have a good approximation of your device performance with doing the multi-physics simulation. I'm quickly going through the software to show you how it works. This is the area of the ANSYS electronic desktop, which in all of the ANSYS electromagnetic or electronic products are included here. As you can see, RM Expert, Maxwell 2D, Maxwell 3D, and also you have the circuit design option and Simplorer, which are the main tools for the motor designs here. So as I mentioned, RM Expert has different machine type as it because it's template based. So if you select one kind of motor or machine, so you can see it here, you have option for changing the circuit, changing the slot dimensions, and based on your design requirement, and also poles and the magnet type, and you can go to the library and change the material or import your material. So these are the options that you have to make some changes, and then you should do this, and then in the end you can do the analysis and have some results. But as I mentioned, the good thing about this template RM Expert is that it can do some analytical analysis and show you the performance of your design. But if you want to do the further analysis, like doing the finite element analysis, you should right click on the setup in under analysis and say create Maxwell design. It gives you the option to convert it to 2D or 3D design. I don't want to create it here now because I already did that. So as you can see here, just I'm going to show you the design. So as you can see here, this is the model in 2D that automatically created by the RM Expert. So you can see the model in 2D, and here is basically the tree that shows all the material and objects that you have here, your excitation, which is a three-phase motor, and also after running the simulation in the result section, you easily can plot the result like the torque or winding currents, or you can look at the magnetic field or flux distribution. Also, when you run the transient simulation, you can easily animate have the animation and look at the how the flux changing. These are the options, and these are the kind of result that you can see, and or also you can do the post-processing and find the result that you are interested more. Also, you can convert the exact model to the 3D model. As you can see here, it's automatically created by RM Expert. Although you can create your own geometry from the scratch, but this way it's going to be much easier. So even in the 3D model, also you can do some analysis and look at the result in the 3D model too. So this is the software that you see here, and it's basically the GUI is really user friendly, and it's easy to work with that. So I'm gonna continue the presentation. I'm going through one example to show that how how software is working, and showing you some result about it. Here is the A case study, we have a permanent magnet synchronized machine. The goal here was to optimize the machine performance. So as you can see here, this is the 2D model. We have this section, this tree that shows all the material, all the objects that are here, a stator, magnet, rotor, shaft, and everything, coils that which are included and listed here. And also this section is all your design setting, like the excitation part, the windings, defining boundary condition, especially here that we took advantage of the symmetry of the model, defining the motion setup. Also, if you have some specific requirement for meshing, you can have the mesh operation, and you should design, do the setup analysis, like the timing for transient analysis, and then in the end you can look at the results. So the goal here was to reduce the cogging torque and maintain the flux in gap and minimize the magnet side. We had a nominal design with this, so this is the initial design or nominal design result for the cogging torque. So, and also here is the flux lines that you can see here. So we define, you can easily define some parameter to use the optimetric option and do the optimization to see what would be the differences in your design, and what would be the performance in which size, which value of your variables or parameters your model gonna have the best performance. So for this case, we have a magnet thickness as a parameter here. You can see the magnet thickness is one of the parameters, and also pole embrace is another parameter of the this design, and pole offset, which another parameter. So with changing these parameters and doing the optimization, we want to find the best performance. So after optimization, you can see here there are a lot of iterations to find the best result, and you can see here the cost function, minimum cost function. So we have some options here for different value of the parameters. So if we look at the choose the best result, these parameters, these values were are from the optimized design. For the optimized design, the red curve that show you how is the cogging torque, but the nominal or initial design that we had was like that. So it shows that optimization really help you to get the best performance of your design. And also you have the you can look at the loss distribution as well. So if you have the loss, there's like eddy loss, core loss, wire, like a copper loss, and all losses that you have in your model, you can bring it to them like a thermal analysis software, like a mechanical, to look at the to do the thermal analysis and look at the temperature distribution. And the other option for like a multi-physics simulation is you can easily, in the Maxwell model, you can easily create a thermal link for ANSYS Mechanical. So when you have your design and the analysis in electromagnetic is done, you can easily use the thermal link and bring the losses, the calculated loss by Maxwell to the mechanical. So you can set your transient limit or timing and bring it to the ANSYS Mechanical for thermal analysis. It's going to be imported to the ANSYS Mechanical as a load for heat generation. Basically, it's reading from the Maxwell design. and doing the mesh and also thermal analysis and showing you the temperature in your design. So there are different methods for the cooling. So you can see the different method for cooling: forced water cooling, forced air cooling, natural air cooling, and look at the temperature of your device. Basically, forced water cooling here you can see is the most effective, and natural air cooling is the least here. Also, you can do the bring the force density from the Maxwell electromagnetics calculation and in the and look at the results in the mechanical. So you can see the values here and look at the force on the tooth. Also, you can study the stator radial deformation based on the forces that you bring from Maxwell to the mechanical. You can easily look at the deformation versus time and see how it's changing. And also you have an option for doing the modal analysis and look at the resonance frequency and look at your model in different resonance frequency. That was all that I want to present today. I hope that this presentation was helpful for you. So if you have any question, you can write it in the question box and I will try to answer it. So I'm going to give it a minute or so to, if anybody has a question. Okay. No questions, so I'm gonna end the meeting. Thanks for the attending. If you have any questions, you can call us or send an email to info@Ozen Inc. We will be happy to answer your questions and help you. Thank you so much.